Now let's move on to indexing. Yeah. What is indexing? We did a little bit of this just earlier. An index is a number that refers to an item in a certain position in a data type with multiple values. It's similar to that of lists for Numpy arrays. So yeah, so starting from 0, matrices are indexed as such. Name of the matrix, your row number, and your column number, or sorry, your row index, column index. So you have some examples there, but we also have some examples over here. So we have my mat, that's the name, equals np.array, and you have essentially 3 arrays inside this big array. Now, if we want to grab the number 3 from this, we would say, we would first have the column index. So again, 0 onwards. So it's in the first column, so that means that it has an index of 0. And then, sorry, it's in the first row, so it has an index of 0. Then is the column index, so it's in the very last column. So let's count 0, 1, 2. So it has a column index of 2. And therefore, you would have my mat 0, 2. That gets you 3. And then you can also take entire columns or entire rows. In this case, we have an entire row. My mat at 1 equals that, 0 and then 1. It is at index 1. That column, that row is at index 1. And now moving on to slicing. Ooh. Slicing, start, stop, step, or slice notation is a method of grabbing parts of an array or list. So if you want to get more than one value, then you would use slicing. So the way this works is this is our array, nums, which is short for numbers. And you write the name of your array, and then the way you denote the values you want to get is you have your start value, which is 0, starting at the very beginning, and you're going all the way up to 5, which in this case is exclusive. So all the way up to index 5, not including index 5. So 0, 1, 2, 3, 4, 5 is 9, but again, not including 9. So up to, but not including 9, is just up 5 up to this 4 right here. And that's exactly what we have returned. The shorthand version for writing this is if you're starting from the very beginning or ending at the very end, as we'll see in this next example, you can actually omit that 0. So you can just have a colon and 6. In this case, if we have a colon and then 5, it will return the exact same thing. And so right here you have nums, and then you have colon 6. So everything up to, but not including the thing at index 6, which is just one more than the thing at index 9. So, sorry, the thing. It's just one more number added to the end of this array right here. So 0, 1, 2, 3, 4, 5, 6. We're not including the 6th, so it's just 5 up to 9. And then right here we have 5 going onwards. Except this is gonna get really confusing, but you don't. Oh wait, no, I'm sorry. 0, 1, 2, 3, 4, 5. Yeah, okay, I'm so sorry. So the beginning is inclusive. So 9 is at index 5. So you have 5 and you go onwards. Okay, now let's say we want to use slice notation to do some indexing on a matrix or a two-dimensional array. This is our matrix, my mat, np.array, 1, 2, 3, 4, 5, 6, 79. It's a 3 by 3. So let's say I want to grab this top right corner right here, the 2, 3, and 5, and 6. The way we would do this is kind of like having two separate slice notations. We have one for the column, and then, sorry, one for the row, and then one for the column. So for the row, which is on the left side of this comma right here, is :2. So 0, 1, 2. It's everything up to but not including the row at index 2. So it's just the first two. 0, 1, 2, not including that one. So it's just the rows at index 0 and index 1. So then you have a comma to separate the slice notation for the rows and the slice notation for the columns. So for the columns, we want 2 onward, because we want 2 and 3. So 2 onward. So the index would be 0. We don't want that one. 1. We do want index 1 onward. So the column is 1 and then colon and then nothing after that because it's just 1 onward. And that returns 2, 3, 5, and 6. And now let's look at broadcasting. Broadcasting kind of builds off of slice notation. Here, one second, let's move the... Oh no, never mind, we're still on this slide. Okay. So broadcasting is a way to use slice notation to change the array, essentially. So here, and this is a perfect example of using that arange method that we talked about. So in this case, we're going from 0 to 11, again, exclusive. So up to, not including 11, so that's just 0 through 10. And this is right here, this colon. Just thought I'd show you this. This is how you grab, using slice notation, everything in the array. So now here we're grabbing everything up into 0, 1, 2, 3, 4. Yeah, so index 5 and back. And now let's say we want to change those first 5 numbers to 100. This is how we would do it. We would just have slice notation, grabbing those first 5, and we would set them equal to 100. And then once we print out that original array, you can see that the first 5 numbers haven't changed to 100. Now, the thing about that is that once that is done, that is your new array, right? It's not like you didn't create a copy of an array and change that. You change the original array. So if you want to reset it, then you can do that. You just use the original code that you used to create the array. But if you want to create a copy of an array to make changes to, then you can have a variable and use arr.copy, or whatever the name of your array is, .copy. And what that'll do is create a copy of your array, of the original array. So then if we want to broadcast something, so arr.copy, we're changing everything to 55 in that copy, then if we call the original array, you'll notice that it's unchanged. So with that done, let's get to work on this next bit. So what this piece of code is, arr less than 5. This essentially loops through the entire array and returns either true or false based on whether or not the numbers in it are, in this case, greater than 5. So 0, 1, 2, 3, 4, 5, those are all not greater than 5. 6, 7, 8, 9, 10 are greater than 5. So we have 1, 2, 3, 4, 5 true, and then the rest are false. Now, if we want to return a section of the array only where this condition is met, we can use this following syntax: arr at arr greater than 5. And this will return only those numbers that are greater than 5. It'll return an array only where those numbers are greater than 5. And now let's demonstrate the np.where method. So we have this array A that goes from 0 to 9. And if we want to, this is essentially like changing an array based on a condition, essentially. So we have np.where A is less than 5. X is, this input, this A is like what happens if that condition is met. So in that case, if A is less than 5, it's just A. It's just the original thing. So, in that case, A is less than 5. So 0, 1, 2, 3, 4, those remain unchanged. This next argument is what happens if this condition is not met. So if A is not less than 5, so 6, 7, 8, 9, we'll have 10 times A. So, 5, 6, 7, 8, 9, 10 times A. So 50, 60, 70, 80, 90. And that's the array that is returned. Now, let's go on to array operations. Oh, did we do these? Yes, we just did these. Alright, array operations. Here we go. This part is pretty simple, but essentially, with arrays, and this is different from lists, this is a really cool aspect of arrays that you can't do with lists. You can perform mathematical operations on them, so addition, subtraction, multiplication, division. You can add arrays together. So we see right here, and this is how it's different from lists. If you try making a list A and a list B, and you add them together, they will literally, like join them together. So you have, these first 3 numbers are your A, and then these last 3 numbers are from B. But if you have arrays, so you can see, A equals np.array, A, we're casting these lists as arrays, and then we add them together. Now we have, the arrays have been added together based off of their indices. So elements 0 from both of the arrays are added together, so 1 plus 1 is 2. Elements from index 1 are added together, so 1 plus 1 is 2. And then elements from index 2 are also added together, so 1 plus 2 is 3. And that's returned there. Now, something to note, be wary of the dimensions of the matrix when you're adding matrices together. And also don't divide by 0. So, for example, let's say we have matrix X and matrix Y. Each of these are matrices, except one has one more array in it than the other one. If you take the one with the least number of arrays, and you subtract this matrix X right here, then what will happen is essentially matrix X will be subtracting from nothing, because you could make the argument that 1, 2, and 4 will be subtracted from 10, 9, and 8. 2, 4, and 6 will be subtracted from 7, 6, and 5. But what's to do with this 3, 6, and 9 right here, right? It doesn't have a counterpart to work with, and so it's going to throw an error right here, as you can see right here. So don't do that. Be aware of how much you have in each matrix before you go on doing stuff with it. And then another thing to be wary of is dividing by 0. So here we have 2 arrays. One is named AB, one is named CD. And you can see CD right here, we have 0 as one of our elements. So 1 will be divided by 0, and it's going to get this. INF stands for infinity, which is not very helpful. Infinity is not a number, and it's going to give you a warning essentially, which is not quite an error, but it's it's not good, just because you can't work with that. So be wary of that. And another thing that I thought I'd throw in there is you can actually raise arrays to powers. So if we want to do, if we want to square an array, we would do AB and then 2 asterisks and then 2. And so, again, AB is an array 1 and 2. So if we raise that to the second power, we get 1 times 1 is 1, and then 2 times 2 is 4. That's a quick little thing I thought I'd throw in there. Alrighty, thanks for watching. Hope you have a great day. Bye-bye.